Hi there. Today, we will resolve another system of equations using the addition technique in our lesson. In this system, the first equation, 5x plus 11 units equals 8, and the second equation, 10 times x minus 7 times y equals 74. We indicated that we would resolve this system using the addition method, yet in these two equations, we do not observe the variable that has equal coefficients. In the first equation, we have 5x, and in the second equation, it is 10. The variable y is 11y and minus 7. Therefore, we need to transform one of these equations. You may make the coefficients of y equal, but then we must multiply the first equation by 7 and the second equation by 11. Yet, I want to focus on the variable x. In the first equation, the term x has a coefficient of 5, while in the second equation it is 10. Let's multiply the first equation by 2. Just one equation. So then, if I were to multiply the first equation by 2, I will arrive at 5x multiplied by 2 equals 10x, plus 11y multiplied by 2 equals 22y, and 8 times 2 results in 16. We will rewrite the second equation. 10x subtracting 7y equals 74. At that point, the coefficients associated with the variable x will be equal to each other. At this stage, we can take the second equation away from the first one. As a result, we will have 10 minus 10x. This is 0. X. Let's write 22e minus this minus and negative 7e. I write this to keep track of the sign. 16 minus 74. Consequently, we omit 0 times x. 22 minus negative 7. This indicates a plus sign. Thus, we will have 29 equals 16 minus 74 equals negative 58. Therefore, y is negative 58 divided by 29, which equals minus 2. We found y's value. Next, we will substitute this value into any of the equations. You may use the equation you derived, or you can substitute it into the original equation. Let's plug it into the second equation. 10x minus 7 multiplied by negative 2 equals 74. Then 10x plus 14 is equal to 74. 10x in this equation is equal to 74 minus 14. Keep in mind that when moving to the other side of the equation, the sign will change. 74 minus 14, which is 60. As a result, x equals 6. We should note the answer. 6 and minus 2. You could ask a question. Why did we multiply by 2? Can we multiply by negative 2? Yes, we can multiply by negative 2. If I multiply by negative 2, let me also write this scenario. If I multiply by negative 2, the first equation, as a result, I will get minus 10 times x minus 22 times y equals minus 16. The second equation will be rewritten as 10x minus 7y equals 74. But then, if the coefficient of variable x in the first equation is minus 10, and in the second it is plus 10, to cancel out the variable x, we will add the second equation to the first equation. Then we will get minus 10x plus 10x results in 0. X. Negative 22 plus negative 7y equals negative 29y. Minus 16 plus 74 is 58. Thus, from this equation, negative 29y equals 58. And then y equals also minus 2. I won't calculate the value of x since we also have a value for y, which is negative 2. Thus, x will also be 6. You just need to substitute this value into any of the equations. Thus, our group, we tried to solve this system in different ways. In one case, we multiplied by a positive number 2, while in another case, we used a negative number. When the coefficients of our variable x were equal and had the same signs, we performed subtraction. And when we obtained coefficients that had opposite signs, we summed the two equations. When solving a system of equations, you can use any method. In our next class, we will solve the system of equations graphically. For today, our lesson is finished. Goodbye, see you later.